everybody. Today is Thursday, February 7th, and yet again I won't be there today. And also, again, I want to make sure everybody can hear the video, so I've got this handy-dandy little sign. Hopefully the speakers at my computer are turned on, and it's not just the sound through the projector. Today is our review day. We're going to take our test on Learning Target I tomorrow, and I've provided the sub with some handout, a single handout that looks like this. So it says Learning Target I, Review of Circles and Sectors. On the front side, it's the review of circumference and arc length, and on the back is the review of area of a circle and area of a sector. So I'm not going to actually walk you through every single one of these. I've selected one example on arc length, and 3 examples on areas of sectors and circles. And 3 out of 4 of these are C levels, and then one of them is more of a B level question. Okay. So I think I'll start with this one. So on the front side, and none of these are numbered, but hopefully you can find this one here, right in the middle on the right. That example is asking you to find the arc length of arc AB. So remember, we start by identifying the portion of the circle we're looking at in degrees, and that's a 40-degree section. That's the part. And obviously the total degrees for the entire circle is always 360. So on the left side we have a part over a total in degrees, and now we're going to look at the lengths around the outside. The excuse me. There we go. The arc itself is what we're trying to find. Hopefully you remember that there's a little way to write that down. You can either write it like this in words, but in terms of mathematical notation, it looks like this. Looks like AB with a little kind of curve, or a little, I call it the rainbow symbol on top. That represents this length right here. This little outer edge right there, that's the part. Now, the total that goes with that would be actually the entire circumference of the circle. So if you went all the way around right here, that's the total. And circumference, rather than writing out the word circumference, I'm just going to write down the formula for circumference, which is 2 pi r. Now, the r, instead of writing r, and I'm kind of short on space here, so I'm cheating a little. Instead of writing r, I'm just going to go ahead and substitute the r value. The radius here is labeled as 6 meters. So I'm going to steal that actual value for the radius, and I'm going to put it in. Okay. So part is 40 out of 360 total. The arc, this little section, out of the entire circumference total. So part over total equals part over total. That's the overall theme here, folks, whether we're dealing with a part of the circumference or a part of the entire area of the circle, which is called the sector. That's our proportion and how we initially set it up as a general concept. Part over total equals part over total. Okay, so what do I do with all this? Well, some of you probably want to convert everything to decimals, which is okay. It's just that then you have to trail along all those extra decimal places all the way to the end of the problem. I think I'm actually going to try to do that. You just have to be really good at making sure you use continuous keystrokes on your calculator so you don't lose any of those decimals. And that's what I'm going to do. So I'm going to show you my calculator as we go. Alright, so to start solving any proportion, you cross multiply. So I'll have 360 times the arc of AB equals 40 times 2 times pi times 6. So that would look like this. There we go. Okay, 40 times 2 times pi times 6. And remember, we don't use 3.14 because that's a decimal approximation. That's chopping off that decimal. We don't want any chopped off stuff. No, we only round at the end of the problem. So we use our pi button. Not any rounded. Okay, look at all those wonderful decimal places. Oh, so good. Okay, so we're going to keep all that. Keep it all. See that 0.964474? We're keeping it. We're not throwing anything away. So we got 1507.964474. Okay. Now really all we have to do is one more step. And as long as we keep all this on our calculator, shouldn't be a problem. We're going to divide both sides by 360 now. Okay. And on this side, obviously the 360s cancel. And on this side, we should have this still on our screen, the 1507.964474. And now we're just going to divide that by 360. All right. So we get 41.8879 approximately. 41.8879. Now, at this point, we have arrived at our final answer. We've calculated the arc length of AB. And so now we can round off an answer if we want to. Obviously, at this point, I don't need all my decimals anymore because I've arrived at my destination, my final answer. So, you know, we're used to rounding stuff off to the 10th, so let's go ahead and do it that way. So, arc length of AB equals 41.9 if I round this off, and we're measuring in meters. So that's going to be my final answer for this example. So if you want to pause at this time, make sure everybody gets this example down. I'll hold it as still as I can so you can pause the video. Pause, pause, pause. Okay. So that's one of the questions on the sea level. I believe, although I'm not looking at the test right now, I believe there's 3. So if you flip over the page, you'll see the other 2 examples from the sea level. Yes, there's 3. So 1, 2, and 3. So again, we're kind of looking at in the center of the page. All right. So finding the area of the circle. Well, that's a pretty simple formula. The area of a circle equals pi times the radius squared. Now, I've never liked how this is written because we always square the radius first and then we multiply by pi. We kind of, it's like reading right to left. It's kind of odd. But in terms of the order of operations, we always do exponents before we do any multiplying. So in that case, it makes sense. Following the mathematical order of operations, we would square the r first, and then whatever that value is, we would multiply it by pi. So that's what we're going to do, as always. All right, so we have our pi. Again, we're using our full button on our calculator, not an approximation for 3.14. No, no, no. Our radius is clearly labeled here. The radius is the distance from the center of the circle to the outside edge. It's essentially halfway across the circle in length, so that's 5.2. So I'm going to go ahead and square this first. I always do things in separate keystrokes. So first I square my 5.2. I'm trying not to get glare here. Okay, which gives me 27.04. Which makes sense because 5 squared is 25, so 5.2 squared is just a little bigger than 5, so I would get a number that's slightly bigger than 25 when I square it. Okay, so I'm going to take that, and now, second step, multiply by pi. Okay, and I'm going to go ahead and round that off. So I get approximately 84.948. 66535. Oh, okay, let's round it off to the nearest tenth, which would be 84.9 inches squared. We write it inches squared, we say it's square inches. On the first time we practiced this year, there was only a couple people, I think, that had this little square over here. But for those few people, and you know who you are, make sure that when you write your area units, that the square goes after the unit, not over here next to the number. That's not good. Okay? Alright, and then the last C example is finding the area of the shaded sector. So just like with the arc length, we're going to create a proportion of parts to totals, and it's always going to start with these degrees, the degree of the central angle out of the degree of the entire total circle. So over here, how many degrees is that? Well, it looks like the shaded sector is 160 degrees. That's the part of the degrees of the circle we're looking at out of a total circle degrees being 360. And then on the top, we're finding just the shaded portion. That's called the sector area. So I'm just going to put A for sector area on the top. Now if I had the entire circle shaded in, that would be the area of the circle. And instead of writing the words area of circle, I'm going to write in the formula for the area of a circle, which is pi r squared. But again, this is the shaded portion on the top, that's the part. And the bottom is the total thing, would be if I were to shade in the entire circle area. So area of this shaded portion compared to area of the whole thing shaded in. Part to total equals part to total. So I've set up a proportion now that relates the portion of degrees to the portion of a shaded region. And I actually do have a radius. They gave me a radius. They're labeling the 10 here right in the middle on this line segment here, which is the radius. So I'm going to go back a second and I'm going to erase my R. And in that place, I'm going to put the value 10. Like so. Hopefully you can see that there's not too much glare there. Okay. So I'm going to need to simplify this down here a little bit. Obviously I need a 10, I have a 10 squared, and I'm going to do that first. 10 squared is 100. And then once I have 100, then I multiply by pi. Okay. So a lot of decimal places. I'm going to keep all these wonderful places here. I don't want to chop them off or throw any of them away. So I have 160 over 360 equals A over this big old number, 314.1592654. Wow. Okay. Now it seems to me I'm ready to do some cross multiplying. I've simplified everything I can individually, and now I'm ready to cross multiply. So this way diagonally I'd get 360 times the area of the sector. And this way diagonally, I still have this on my calculator screen, so I'm going to multiply it by 160. See what I get. There we go. Times 160. Alright. So, oh, big number. But don't let those big numbers scare you. Sometimes you're going to get some really big values in the process of calculating these solutions. Okay. And then we're almost done. All I have to do to isolate the A variable is to divide both sides by 360. So I'm kind of running out of space, so I'm going to now go ahead and just kind of steal that line of notation that I just wrote. Normally I would write it again, but okay, so now I'm going to divide both sides by 360. And the area of the sector is approximately this number divided by 360, so I've already got that on my screen, so I'll just divide by 360. And I get 139.62634. Alright, now it's okay. Now I've reached my destination. I can round off if I actually want to. So our standard is rounded to the 10th, so I'll go ahead and round it off to the 10th. Be 139.6. This is area. We've just calculated the area of the shaded region. So area is in inches squared. There you go. So I'll hold these up a little larger so everybody can see them better. So those are the two solutions, or the last two solutions for the C level. So if you want to pause the video now so everybody can write these down, make sure everybody has them all written down. Go ahead and pause now. Okay, so that's what the sea level looks like. There's 3 examples. 1, 2, 3. Okay? So if you know these 3 concepts, if you can do these 3 problems that we just did, you'll be able to successfully navigate the sea level on the test tomorrow. Okay, so I only have 1 B-level example, and that's down in the bottom right-hand corner. Now these are actually labeled, so it's number 4 in the bottom right on the back side of the review. Okay? Alright, so the formula, or the general setup, is very similar to the one we did up here, because this one's asking us to find the area of the sector. Find the area of the sector. This one has given you the area of the sector. So we're going to use the same basic setup. The proportion of partial degrees to total degrees equals area of the sector, the shaded in portion, versus area of the whole circle, which would be the whole thing shaded in. Okay? So let's see. Let's start with just the basics. So the degrees of this sector are 70. The whole degrees total in the circle, 360. And then over here, they give us the area of the sector. That would be the numerator, because that's the part that compared to the whole here. So I get 123.45 square meters for the area of just the sector. And then the total down here would be just shading in the entire circle, which is the area of the circle. So instead of writing area of circle here, I'm going to write down the formula for the area of the circle, which is pi times radius squared. Okay. Now you can see here they're asking us to find the radius of the circle, and look at that. So that's the only variable that we have in this entire equation is r. So we should be able to cross multiply and calculate the value of r. And that'll be it. We don't have to do any more steps. Just solve this to find r. Okay, so cross multiplying. Here's how I would do it. I would multiply 70 times pi on my calculator. 70 times pi. Okay, I know there's a lot of decimals there. I'm sorry. 219.9114858. So if I multiply this way, I get 219.48858. And then don't forget the r squared. So 70 times pi is this, and then bring along the r squared for that multiplication diagonal this way. Then, multiplying this way, 360 times 123.45 gives me 44,442. A lot of fours in there. I've had a little confusion with the fours. Okay. 44,442, as they say in Boston. Alright. At this point, what I'm going to do is this big old number, just like we did up here with the 360, I'm going to need to divide that on both sides. See that? Any number in front of my variable, I want to divide that away. So believe it or not, I'm now going to divide both sides by this big whole decimal. Oh no! Yes, I am. Alright, so I'm going to divide here. Again, I'm saving space here by using the line I've already written. Normally I don't like to steal my lines. I like to write them separately, but as you can see, I'm running out of paper. Okay, so these values cancel, and I get r squared on the left, and on the right, I have this big old number divided by that one. So I already have the 44,442 on my screen. I'm going to divide that by 219.9114858. Now notice I kept all my decimals. That's good. Okay, so I have 202.0903994, but I'm not done. I'm not done because this is r squared. I want to find the radius, not the radius squared. So I have one little element now to remove from this equation so that I can have just r on the left side, and that's this square. How do I get rid of a square? You guys already know this, most of you, right? Use a square root. So if I square root on the left side and I square root on the right side, I will finally be able to figure out what r is. So here on the left, the square and the square root cancel each other out, whereas on the right, I just need to take the square root of that last value on my screen, which gives me 14.21585,029, and if I rounded that off to the nearest tenth, I'd get 14.2 meters. Oops. Alright, now I'm going to hold this up so y'all can see it a little bigger and clearer. There you go. Alright, so that is everything I wanted to share with you today. I'm sorry, I'm just looking at this key that I made. Before I stop the video, I'm just going to make sure I did everything correctly here. At 40 on 360, so 40 times 2 times pi times 6. Yeah. Okay. Yeah, I did that right. Okay. Alright, so what I'm going to do is I'm going to provide the substitute teacher with a key, a solution key for the front side and the back side, and they can share that with you. I'd like you to try some of this yourself, kind of help each other if you need to, but I don't want you to look too much at the key. I'll probably suggest, in fact I'll just go ahead and say that I only want you guys to look at like the last 10 minutes of the class period. So between now and then, I want you to try to work through a lot of the rest of these on your own, and then near the end of class, the sub can put the solution pages on the document camera so y'all can see what the correct answers are. Okay? Alright, now I am in the building today, I just can't be in class, so be good. The sub might call me. If I get called out, I may maybe come down there and deal with y'all. You'll be in trouble. Okay? So be good. Alright, see you tomorrow.